I'd like to welcome everyone who's here this evening, who's viewing live, and those that are also viewing remotely, to Sunset Lodge number 369, Philosophical Society Discussion Evening. Our lecture series this evening is going to be with Brother Theo, and the topic is the ontological implications of Masonic thought. So please, everyone, a warm welcome for Brother Theo.
In the beginning, there was the great architect of the universe. The great architect said, "Let there be light." And hence, the universe, as we know it, was born. Through this, all the laws of physics, of mind, of thought, of reality came to be from this moment. The entire universe in which we interact came to be. And hence, the great architect's metaphorical hand extended its grace to mankind. And we were made in his image. This emanation from Godhead down into our own existence has also been expressed from other schools of thought in the esoteric tradition. Here you'll see, for example, in Neoplatonism, the one emanated into the nous, which was the divine mind, which emanated into the world soul, and this emanates into our sense selves. And when we intuit a higher divinity above our animalistic senses, we are reaching up through the emanations. So too does the Kabbalah reference such emanations, from the crown or the Keter down to Malkuth and everything in between. That's one example of explaining how the universe was created. But here's another. In the beginning, there was nothing. Or perhaps a singularity. In this singularity was the Higgs field. It was bosonic, full of boson quantum particles. It was fully mathematically symmetric. It was pure frequency. It was a oneness. And from that singularity, the Big Bang happened. This was an asymmetry function, where matter then was created, where quantum particles known as fermions came to the fore, which went by something called the Pauli exclusion principle. Every fermion took up a different space in time. A different quantum number was assigned to each of those fermions, creating extension. It then created space-time. Matter was born as we know it. Oneness diverged into otherness. And through billions of years, hydrogen atoms converged gravitationally into proto-matter, which converged further into stars, which then created the processes to spew out all the elements that created the planets and the asteroids. And those planets, billions of years later, some created the perfect conditions to house ecosystems, which then manifested into single-celled organisms, which then evolved into us. Are those two stories different? So let's bring this back to why we're here today. How does this have to do with Freemasonry? Well, let's look at two of the landmarks from Mackey's landmarks of Freemasonry. Two of the, what might be considered some of the most important. The first being, to point out number 19, that a belief in the existence of God as the grand architect of the universe is one of the most important landmarks of our order. It's always been deemed essential that a denial of the existence of a supreme and superintending power is an absolute disqualification for initiation. Landmark 20, the next one, that a subsidiary to the belief in a grand architect is the belief in a resurrection to a future life. Now, as Mackey says, the landmark is not positively impressed upon the candidate by exact words, the way that the previous one is. But the doctrine is taught by very plain implication. In other words, if we are to accept the concept of a grand architect, then we are to accept something beyond materialism, and hence beyond mere matter making up our own compositions. And so by extension, the existence of a soul. And then, if we accept this, what does this mean about the implications of reality itself? Reality has matter, and it also has soul stuff. So what is that? Now, as we all know, we've heard many times, Freemasonry is not a religion, never claims to be, but there's no doubt it certainly has spiritual elements, especially in the more esoteric aspects of the order. So a few quotes from Albert Pike from Morals and Dogma. Every Masonic lodge is a temple of religion, and its teachings are instruction of religion. Page 213. On page 524, he wrote, though Masonry is identical with the ancient mysteries, it is so, in this qualified sense, that it presents but an imperfect image of their brilliancy. Hence, beyond the foundations of mere brotherhood, fraternal brotherhood, there is a deeper spiritual element running through Masonry's veins. And hence, implications about the nature of reality itself. So it is inherently philosophical. It is inherently connected to the implications of what science attempts to do. Why? Because we're describing reality from different angles. And so if Masonry is actually spiritual, that means that it cannot be materialist, it cannot be nihilistic, it cannot be anti-free will, and it cannot be atheistic. Hence, by definition, it must be an idealist philosophy. It must be imbued with meaning. It must assume that we have free will. And then it is also focused on the divine for what is the grand architect. Now, some of us may have a pretty good grasp on the history of Freemasonry. And those of us that do will know that there is a deep tradition of Enlightenment thinkers in the order. When we think of Masonry going back hundreds of years, especially into the ages when mainstream religions often came at a head with the order, and hence the requirement for its secrecy in those times. Individuals like Sir Francis Bacon, John Locke, even Sir Isaac Newton, Voltaire, and Adam Weishaupt were all members of Masonry. And so it's no coincidence that with members like these, there's going to be an element of higher thought, philosophical thought, and questions about the nature of reality. And so, using that as a foundation, let's use our rational and intuitive faculties to philosophize about that. And let's clarify some of our thoughts. By doing so, we can figure out what cannot be true, what must be true, and so we can stand on the shoulders of the giants of Freemasonry, and hence gaze into the heavens themselves. So I used a word in this, which is a little heady and maybe a little much for many to understand. Ontology, big scary word. But what does ontology mean? It's very simple. It's a strand of philosophy concerned with the nature of existence. According to Wikipedia, it is the philosophical study of being. It studies concepts that directly relate to being, in particular, becoming, existence, and reality. So when we discuss what the nature of reality is, that's all ontology means. So going back to the pre-Socratic philosophers, these were some of the Greeks that were particularly focused on the nature of ontology, trying to ascertain what's the universe made out of exactly? What is the nature of the universe? Heraclitus said it was fire. Thales said it was water. Anaximenes said it was air. And Pythagoras said it was number. Hopefully, by the end of my talk today, I will vindicate the latter in his assertions. And one more word to know, next to ontology, is epistemology. And I'll explain why we should understand that. Rather than like ontology being about what the nature of existence is, epistemology is how do we arrive at the knowledge of that? What is the toolbox that we use to arrive at what we can then say we have knowledge of? How do we know what we know? What is our method for arriving at the things that we're confident about? What are our tools? Well, I can point out 4 methods of ascertaining beliefs: faith, senses, intuition, and reason. That's more or less what we use. That's the toolbox. And are they all equal at arriving at truth with a capital T? So let's break some of these down. Faith is simply the firm belief in something for which there is no proof. Its main adherents, philosophically, are the exoteric Western religions. It's based mostly on believing stories, and in terms of Jungian functions, it most correlates with the feeling function. The senses is very dominant in today's modern scientific paradigm. I'll believe it when I see it, using physical instruments to probe the visible universe. It's the method of empiricism. It's about physical evidence. In terms of Jungian functions, it most correlates with sensing. What can you see and feel? Concrete, either with your own senses or with physical instruments. Then you have intuition. Intuition brings us more of a sense of mystical transcendence. The gut feelings, just knowing, being able to see between the lines, connect the dots deep down. This philosophically is most associated with Eastern religions like Taoism, Buddhism, Hinduism, and in the West, the esoteric tradition like Hermeticism, Neoplatonism. It tends to preach a sense of oneness with the universe. In terms of Jungian functions, of course, intuition. And then you have reason. This is hard if-then statements. These are statements of logic, statements of mathematics. It's pure rationalism. Things that must be true a priori by their very existence, by their very definitions. This is based on logical proofs. And in terms of Jungian functions, it's based on the thinking function. Now consider, when you think about these 4, are they all equal? I will ask again. Not to arrive at a truth that's comfortable for us subjectively. Not to arrive at a truth that most adheres with the mainstream paradigm. But to arrive at truth with a capital T, which of these is more powerful than the other? Or are they all equal? So often, when we look at philosophy, we see dichotomies. One of the Hermetic principles is the concept of duality. So, in other words, as far as this goes, all concepts basically have definitions. And when you define something, you inherently define what it's not. So by clarifying a few dichotomies to come, we can understand the ontology of esoteric Freemasonry and Enlightenment philosophy. This way we can figure out what things are by figuring out what they are not, and hence gain a greater clarity into these matters. One extremely important dichotomy is the difference between syntax and semantics. So when we describe, for example, how the universe was created, I started with two versions of that story. One was a narrative. The other was describing principles. The first was semantics. It was a story. It was a mythos. It was a narrative, right? Syntax, on the other hand, is a pure breakdown of logical precepts, formal causality. So, for example, going back to ancient times, in Greece, the birthplace of Western philosophy, the person that is considered the first philosopher, actually, in the early rise of the classical era, arguably in the archaic era, was Thales. Thales, if you Google who is the first philosopher, this is who comes up. He was the one that said the earth, or the universe is made of fire. In other words, no, he didn't say fire, he said water, excuse me. In other words, he imagined a flowing, formless entity that ultimately manifested into different levels of form, similar to what would be reflected later by Schopenhauer's will. But the key is he was naming a process of the universe. Compare this to Moses, who didn't describe what God was made out of, or what the universe, what principles the universe adhered to. He simply created a narrative. And this is the difference between syntax and semantics. So when we philosophize tonight, we're going to focus more on syntax, because that's how we take the microscope to the matter to understand not only that there's a great architect, but by what principles does the great architect itself adhere to? Immanuel Kant discussed the dichotomy of noumenon and phenomenon. You are all, I'm sure, very familiar with the word phenomenon. So when you look around and we see things as they manifest, the phenomena are outside of the mind. It's the things that we're perceiving out there. It's the percepts. It's the manifestations. It's outside there. It's extended. It's what science probes. But when you think to yourself and you get brought to tears by a symphony or a play, when you work yourself up emotionally, when you sit with your ambitions, when you conceive of philosophical ideas, when you ponder your soul, none of these are things that can be studied by a microscope or a telescope. But do they exist? Those are noumenon. They are the archetypes, they are the ideas, they are what is in the inside. Now, according to the modern paradigm of scientific materialism, noumenon don't actually exist. We are all machines having the illusion of existence by the emergence of accidental atomic configurations. Now, why the universe would create such an elaborate illusion, I don't know. This is a more tricky dichotomy because some people believe that empiricism is rationalism, but there's a difference. This dichotomy is most felt by the rivalry between Isaac Newton and Gottfried Leibniz, who were contemporaries, incidentally, both of which invented calculus at the same time. Interestingly, and they did it independently at the same time, interestingly, Isaac Newton was more popular at the time, and the mainstream establishment used his version of calculus, only to realize quite later that Leibniz's version was much more efficient and useful. And so today, we learn the calculus invented by Leibniz. There's a big difference between their two schools of thought as far as the implications that they had on the mainstream down the line. You see, empiricism is the scientific method, which has done quite a lot to bring us many of the things that we take for granted today technologically. But it is fundamentally ad hoc. In other words, it is always after the fact. It is always provisional. It's practical. It's based on common sense. It's based on what we can perceive. It's based, using this previous line, on phenomenon. Rationalism would be the continental school of philosophy, most notably in Germany at the time, to contrast the empirical philosophies that came from England, which looked at reality not from the perspective of let's start with the assumption that everything is physical and work from there, but let's start with the assumption that everything is rational and work from there, and see materialism simply as a subset of rational principles, and perhaps reason that there must be aspects to the universe that are unseen, but yet rational, hidden variables. So for example, Gottfried Leibniz actually was an atomist, but his versions of atoms, unlike today's versions of atoms, were not actual material things, but mental atoms. In other words, singularities. Of course, these could never be probed by any scientific instrument, but he rationally deduced them by ascertaining that you can break everything down infinitely. And if you keep doing that ad infinitum, the one thing that cannot be broken down is an infinitesimal unit. And hence he devised a unit of mind. Now, you can probe this realm using your thoughts, but again, never materialistic instruments. And so this is the difference between rationalism and empiricism. And these are based on the differences between necessary and contingent truths. Empiricism looks at contingent facts, which can be true. For example, if humankind, from the beginning of its inception until thousands of years later, hypothetically, only ever saw white swans, we could say with a fair degree of certainty, all swans are white. However, because we're simply physically looking at outcomes in the physical world, there could be a contingency where that no longer is true. Hence, why scientific theories, which at one generation might be considered almost dogma, can then be overthrown by later theories. Even if the previous theory was proven to have instrumental success, did not mean it was truth with a capital T. As Nietzsche said, there are no truths, there are merely interpretations. And contingent facts that are useful are essentially useful fallacies. Necessary truths, on the other hand, must be true, and this is the essence of rationalism. A squared plus b squared equals c squared, the Pythagorean theorem. Inherent in every right triangle are the squares that they're associated with, and the areas of those squares will always match in that relation. That was true 1 trillion years ago, it will be true infinite years from now, and it doesn't matter how many big bangs happen, that will just always be true. There are many other planets where there might not exist swans. Do you see where I'm going with this? Contingent facts versus necessary truths. Hence, rationalism as a more powerful route to truth with a capital T than mere empiricism. And this closely ties with the dichotomy of idealism versus materialism. Idealist philosophers include Plato, who in the Western tradition is essentially the godfather of the idealist tradition. In the East, Lao Tzu, and later on in German idealism, Hegel. Idealism asserts philosophically that mind is what is primary. The universe, according to idealist philosophies, can range from things of being made up of things like will, made up of noumenon, as we discussed, made up, as Plato discussed, of the forms. It sees the universe as an organism. And schools of thought within the idealist umbrella include panpsychism, or pantheism, or panentheism. In other words, the entire universe is imbued with inherent life and mind. If not life and mind purely, some schools of idealism see material as a subset of idealism. Some see the material world as completely an illusion. On the other side of the spectrum, you have materialism. Now, of course, in the modern scientific paradigm, in the mainstream, you have folks like Richard Dawkins, which is known to most of us in the modern day. But materialism even goes back to the ancient Greeks. Democritus was a famous materialist. And then Marx, of course. This asserted that matter is what's primary. The universe is made up of atoms. It is matter. There are no noumenon. There are only phenomenon. The universe is not an organism. It is a mechanism. It is a clockwork. And it is inherently atheistic. In the East, we see similar dichotomies. We've been very Western-oriented, but according to Hinduism, this essentially is the difference between Brahman and Maya. According to Hinduism, Brahman is the ultimate reality. That is the idealist universe. It is the noumenal universe. It is existence in and of itself. It is based on the eternal truths. It is the infinite. Maya, on the other hand, is the veil of illusion, the veil of ignorance. It is what is shown to our appearances, to our senses. And according to Hinduism, through countless reincarnations, we begin to gain a greater degree of intuition until we ultimately reach nirvana, what Buddhists call nirvana, what Hindus call moksha, the transcendence of the physical domain, the shelling of the veil of Maya, and the emergence into oneness with Brahman. And in the Western tradition, we see, essentially, this is a Hermetic painting. I believe it's a Renaissance Hermetic painting. This is a great view here on transcendence of Maya. What we see in the orb is the world as phenomenon. It is the empirical world. And this individual reaching out beyond this veil is reaching from the empirical, phenomenal, material world into the ideal, mystical world, the noumenal world. So what does this have to do with science? So we might be so hypnotized, so enthralled by the incredible material success that science has brought us throughout the last few hundred years since the Industrial Revolution. But again, as Nietzsche said, success has always been the greatest liar. Thomas Kuhn wrote a seminal work in 1962 called The Structure of Scientific Revolutions, in which he studied the paradigms within the scientific establishment of each time. And what he found is that, unlike what we might think intuitively, that science progresses in a linear fashion from progress to progress to progress to progress. No. How science actually proceeds is by entrenched paradigms, groupthink, assumptions, a few heretics that break the mold, radicals that point out more and more flaws of that entrenched paradigm. And then as a result, a few of the old paradigm thinkers die off, a massive revolution happens, a great shift happens in a short period of time, a new paradigm is established, and a new dogma is established. And this is the Kuhn cycle. Normal science, the model drifts, the implications of its fallacies start to build up, then it reaches a crisis, you have the revolution, the paradigm shifts, and then that becomes the new normal. I'm going to give you specific examples in which this was the case. The geocentric versus heliocentric model. Now, empirically, look at the sun. You see it rising, don't you? Obviously, And it took Copernicus in the modern scientific paradigm to overturn that dogma, which was the dogma of the most learned people of this time. If you went to university and you taught you learned with the top professors, they would have said, of course, the sun revolves around the earth. And when Copernicus said around, some of the folks with the highest IQs, with the most prestigious positions, said, "Oh, this man is a freak," right? Isaac Newton devised a concept of fixed space in terms of his laws. When Einstein came around and provided the concept of flexible space-time through relativity, it overturned fixed Newtonian space and time. And so this is important to know, because in internalizing these facts, the next question becomes, so wait, what does the mainstream scientific establishment today treat as automatic assumption that in the future will be viewed as ignorance? What paradigms are there to be overthrown now? Perhaps it might be a few of the things that the big popes of the establishment put their nose up and call woo-woo and quackery today. And so I'll provide some quotes from some of the smartest folks. Giordano Bruno said, "Truth does not change because it is or is not believed by a majority of people." Thomas Kuhn, who we discussed, said, "All significant breakthroughs are break with the old ways of thinking." David Bohm was a quantum physicist. He said, "A great many people think they are thinking when they are merely rearranging their prejudices." Galileo, "In the sciences, the authority of thousands of opinions is not worth as much as one tiny spark of reason in an individual man." Now remember, if there is an entire dogma among the establishment of all the smartest establishment heads, and they're all wrong, and we all know that in retrospect, it took a single heretic to overthrow them, who was a quack in their eyes. Max Planck, another quantum physicist, and I think this is, in my opinion, one of the most powerful ones to describe this concept, said that a new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually die and a new generation grows up that is familiar with it. And as it's been paraphrased succinctly, science progresses one funeral at a time. The logician Carl Hempel devised a thought experiment called Hempel's dilemma. And what he did is he logically proved that conviction in physicalism or materialism is actually faith. He proved it. And let's explain how he did that. In other words, if someone asserts with confidence that materialist and physicalism is the truth, there's no such thing as noumenon, we were all anti-free will, machine-like clockwork robots, and there's no such thing as anything outside of the space-time domain, that is not rational like they may think it is. It is a leap of faith. And here's why. Here's a fact. We all know that physics in its current incarnation does not explain the totality of reality. There is no grand unified theory yet, and physicists have a long way to go to figure everything out. So we're not there. Given that fact, let's look at two propositions. Those who subscribe to physicalism can take one of two positions in order to arrive at their belief. The first is that they believe that reality can be explained in terms of today's physics. That's false. It cannot. That is a fact. It is not there yet. And so to make this claim is simply a position of faith. Now, if you admit that today's physics cannot explain reality, but that it could be possibly explained by a future physics, well, future physics is an undefined concept. It might or might not. And so to be purely convicted and confident that it can is simply having faith in physicalism. Therefore, a belief in physicalism with conviction is not a rational position. Now, a few dichotomies within the scientific realm within quantum physics. You might have heard of two different types of particles called bosons and fermions. Bosons are, for example, particles like photons. The quantum particles occupy the same state, so they can be superimposed upon each other. In other words, they are, as John Bell put it, and as David Bohm put it, non-local phenomenon. They are not particles per se, but they are force carriers, energy carriers. And they provide the plenum of existence that interacts the entire universe with itself across the whole entirety. They are unity particles. They do not adhere to the Pauli exclusion principle, which does apply to fermions, which are your basic particles, for example, protons and neutrons. These have extension. On the quantum level, fermions do not occupy the same coordinates ever. And that is the Pauli exclusion principle, that every fermion has to occupy a separate coordinate from a different fermion. And hence, extension is the name of their game. They are matter particles. They are division particles. So again, bosons, unity, fermions, division. If bosons and fermions had political parties, it would look a little something like that. Right? Bosons are communal. They're, as Empedocles, the ancient Greek philosopher, discussed in his Nature of the Universe, all is either love or strife. There are opposing forces and connecting forces, kind of like magnetism. You have magnetic force bringing things together, and you have opposing magnetic force. And so the universe is actually, in a sense, Empedocles is vindicated by bosons and fermions. And again, to stay on the scientific wagon here, one of my favorite scientists is David Bohm, who discussed in his theories of the universe something called the implicate and explicate orders, which are also known as the enfolded and unfolded orders. And so the implicate and enfolded orders are non-local, it's unobservable, and there are hidden variables. And hence, something called the EPR paradox, essentially, which is about quantum entanglement, how two quantum particles that are entangled can mirror each other across infinite distances, assumes that their communication with each other is not traveling across space-time, but is enfolded within an implicate order, right? It holographically jumps, or perhaps they're never separated in the first place. And it is only perceived as separate from our space-time coordinates. And that's, of course, contrasted with the explicate and unfolded order, which is local, observable, and it's the variables that are revealed to us. Now, as you can see, the implicate order, while not directly associated with it, you can start to intuitively see the implicate order being overlaid onto the concept of noumenon. And so when we're discussing aspects of the universe, it's important to understand the difference between concepts and percepts. A concept is something you conceive of in your mind, whereas a percept is just simply the incoming information without the value placed on that perception. So percepts are phenomenal. It's the incoming data, where the concepts is the data processing. You see, the percepts is what you sense. The concept is what you make of those senses, right? The percepts are the facts. The concept is the meaning that we make of those facts. So everything I'm talking about right now is extremely conceptual. If I were to show you the results of an experiment, that would be perceptual. However, if an experiment then has scientists from two different schools of thoughts looking at that exact same experiment and coming up with two theories on its implications, you have two different concepts for the same percept. See the difference? And this relates to Descartes, who discussed, to give you another duality, the concept of extension and non-extension. Essentially, when describing the universe, he was a rationalist, he was a mathematician, an idealist. Up to Descartes, who was in the 1600s, philosophy itself was more all-encompassing, to the point where folks that actually dealt in physical sciences were called natural philosophers. And coming out of an older age, there wasn't too much of a difference in the ideology between natural philosophers and other types of philosophers. But what Descartes did is he definitively drew the line between extension and non-extension. In other words, extension is the phenomenal domain where from any given point the radius is greater than 0. Whereas non-extension is from any given point the radius is equal to 0. Now, to Descartes, both of these were literal existences, right? What ended up happening is, following Descartes' Cartesian duality, the continental and British philosophical schools of thought, which were marked by the idealist and empiricist schools respectively, ended up splitting on their own ways. And some idealist philosophers afterwards, like Bishop Berkeley, came to the conclusion that extension is completely false. Whereas empiricists and scientists who ended up leading into the path that led to the modern scientific establishment said, extension, non-extension is non-existent. But does non-extension not exist, or is it just another version of existence? So consider this metaphor. When you're playing a video game, let's say here we have World of Warcraft. You're playing a character, you're going around, you're experiencing the environment, you're gaining the points, etc. You're interacting. You're seeing the colors, you're seeing the world. Now, the truth is beneath that is a digital code that is projecting that world. Only computer programmers can unlock that code. Now, if you can imagine a consciousness projected into this character in the video game, imagine the evolution of these characters starting to probe the world around them, starting to get very good at the game, starting to probe the trees in the game. Perhaps they became experts at a high level of their own game science. They started to become pixelists, who discussed the nature of reality is fundamentally based on pixels. But then maybe there would be another school of thought that said, no, we believe that there might be zeros and ones underlying this. But then the pixelists say, no, look at the pixels. Our scientists in the game world have found these small pixels. Where is your code? Show us. So perhaps we have a code within the noumenal domain, which is the basis for the laws of physics in which we interact. This is a few characters from The Sims. So now to take all these concepts that I've kind of shotgunned at you and put them into camps, there's a great divide now. And I believe that this might well be the next Kuhnian scientific paradigm shift, as Copernicus overthrew the geocentric model, as Einstein overthrew Newton, Perhaps Einstein himself would be overthrown one day. The mainstream establishment now, through massive, incredible advances in science, have now knocked on heaven's door in both directions. They're studying, they've reached the end of ascertaining the Big Bang. They've ascertained the almost mystical aspects of quantum mechanics. And yet quantum mechanics is completely incompatible with relativity theory. So there will be something overthrown. In other words, either one of them is false or both of them is false. That's a fact. So the great divide is between empiricism, senses, phenomenon, materialism, extension, contingent facts on one side, the veil of Maya, versus idealism, rationalism, reason, intuition, etc. And perhaps those on the left side will at some point be the crux of the mainstream establishment. And if this is the ultimate truth with a T, and the mainstream establishment then perceives it as such, perhaps the practical implications of what this means in terms of technologies and in terms of understanding the nature of our existence, when geniuses far smarter than I that can not only ascertain these truths to the deepest degrees, but also provide the technologies to, based on these, can bring the human condition to who knows what level. So according to the latter things, the physical, material aspect, the Big Bang emerged from nothingness because the universe expands. This we know from research. If you take expansion going forward in time and you rewind time, expansion looks like contraction going back in time. And take it to the nth degree, that contraction leads to a singularity. Now, ask the mainstream establishment what came before the Big Bang, and they'll say nothing. Well, how does something arise from nothing? That's a logical inconsistency. Nothing can come from nothing. Every instant of existence was caused by a previous instant. Now, because empiricism can only study what is available to the senses, but the senses themselves are trapped in the very thing that they're studying, like the game character studying the game from the outside. It is only rationalism that can say, there must have been something before the Big Bang, because every instant is caused by a previous instant. That is a logical necessity. So there must have been something, but perhaps it was just unextended existence. And that's, since causality is true, automatically this leads to an infinite regress of eternity. That is how eternity exists, because causality exists. And therefore reason asserts that eternity must exist, because nothing can come from nothing. Therefore there must have always been something. And so the Big Bang was a singularity of mind or spirit, which, to put it in this jargon, it was an ideal bosonic implicate order converting into a material fermionic explicate space-time function. In other words, let there be light. And spiritually, that means that if there was always a singularity, if there was always an implicate order, it never went away, and it never has gone away, and it never will go away. And that means it's the part of the universe that's eternal. Whereas this material part is the mortal aspect. It's contingent. It can or cannot be. So take a moment right now and become aware of your own awareness, because that awareness is an atom. That awareness takes up most physical space. It interacts with it, but it's not the space itself. It's mind. Your sense of I. And therefore, it is connected to that singularity. You were there when it happened. Do you remember? Tesla said, if you wish to understand the universe, think of energy frequency, and vibration. And I think a lot of us intuitively get that, right? The truth is all around us is waves. Light, waves. Color, waves. That's within a small electromagnetic spectrum, ranging, you have radio waves, X-rays, that's all that electromagnetic spectrum, which is just different frequencies. Sound, waves. Quantum particles, they come from waves. So what's not waves? Your thoughts emit brain waves. The ocean cycles are waves. You have seasonal cycles, that's a form of waves. Music, nothing but waves. Your breath is a wave. We intuitively feel somebody's vibes. What's vibe short for? Vibration. What's vibration? Waves. And so, maybe the concept of wave mathematics might give us an insight into the nature of reality, as Tesla asserted. And I'm going to go on a little bit of a leap here and try to connect this with the square and the compass. Now, what I'm about to say may or may not have been the original intention of those who devised the square and compass as esoteric symbols of Freemasonry. Or perhaps it was an unconscious intuition that connected these things. Or maybe I'm just taking a leap, but let me know what you think. So, compasses do what? They draw circles. A circle is an extension of a singularity because every point on the circle is equidistant from every other point. It is the shape that requires the least, the least effort, because it applies to something called Occam's razor, which is the thing that is the simplest in phenomenon. It requires no extra steps. There are no arbitrary changes in the shape. The circle is the purest shape as a result. It is the extension of the singularity. And so I'm sure you're all familiar with this symbol. The circle is drawn by the compass. And so look at the compass. The part that sticks into the paper never moves. That's the singularity. And so the one part of the compass represents being. It's the infinite, it's the eternal, it's the thing in and of itself. Whereas the pencil part of the compass is moving, it's energy, it's contingent. It is how becoming emerges from being. And interestingly, within a circle, given every point on the circle, you can see that every point on that circle actually comprises a different right triangle. So for example, the point on the circle higher up has a longer hypotenuse compared to the other. No, excuse me, the hypotenuse is the same, but the sines and the cosines, are different relationally. But they're right triangles, just like the compass. And so inherent in a circle is trigonometry. And those trigonometric functions have to do with the circular motion. But why is circular motion important? Why is the tracing of what a compass does important? Do you remember what Nikola Tesla said? What is the universe made out of? What is everything made out of? Light, thought, music, quantum particles, sound, waves. And what is a wave? It's just a different perspective of circular motion. And circular motion emerges from a singularity. Therefore, singularities produce wave functions. How many circumferences are there per singularity? Does anybody know what number? What's the amount of the circles that can fit around a singularity? Well, the answer is infinite. You could have a radius of 1, a radius of 2, a radius of 3, a radius of 10 trillion. And so outside of a circle is essentially a fullness of plenum. of all possible circles, which create the one. And each of those circles is simply a different amplitude. And mathematically, there's no reason why anything less than infinity should be the case. Why? Because mathematics doesn't stop infinity. Only the finite stops infinity. And hence there are infinite waves that are being projected. And how many singularities can fit in a singularity? Infinite. Because why should there just be one? It's like the Cartesian grid, right? The x and y coordinates, +1, -1, you have infinite points on that grid technically. So infinite points projecting infinite waves therefore creates the symphony of the spheres, the music of the spheres, as Pythagoras put it. And interacting waves, as our musician friends will know, create chords. And perhaps the quantum wave functions from infinite wave cycles are all around us. The infinitude of energy that interacts with each other, holographically projecting the universe out of the infinite singularities. And hence noumenon projects phenomenon. And so waves interacting with each other, as you can see, because waves are simply circular motion viewed in a different way, is what the flower of life is about. For what is the flower of life? It's circles coming out of singularities, interacting with themselves. And here you have a beautiful pattern that emerges. Now this is a simple 2D intuitive explanation of what I'm describing here. But in reality, there's an infinite amount of circles. But that might look a little sloppy. So you make them all equidistant, you get that pattern. But this gives you an idea of the interference pattern that represents the harmony of the spheres. And when you have multiple frequencies interacting with each other, as you can see on the left, you have complex frequencies that emerge. And on the right, those complex frequencies can mathematically be broken down into its different frequency parts. And so inherent in the combination of frequencies are various functions. And actually what I just described is called Fourier analysis. Charles Fourier was actually a scientist under Napoleon's army, and he was studying heat. That's what he was fascinated by. And he's the one that discovered that heat was actually waves. And then he devised the mathematics of ascertaining this. There's actually a lot of engineering, practical engineering applications of this when it comes to sound engineering. I believe when sound is recorded by an electrical device, it produces this transform, which transfers it electrically, and the transform is then applied, which then produces the sound at the end. So this has practical implications. But ontologically, we are looking at thought waves emerging from minds, interacting with themselves, a subset of which harmonically projects the physical domain, but a large percentage of which don't, and that's the game code. That's the within. So in summary, the universe is a divine mind, the great architect, composed of infinite parts, singularities, which, via geometrically defined wave interactions, thoughts, holographically project material space-time phenomenal fermionic domain, that's the game, from within the ideal frequency noumenal bosonic domain, the game code. Hence, the soul rationally exists as an eternal singularity. So how does this all apply to Freemasonry? Well, one, Freemasonry believes in the supreme being, which is divine consciousness, and an afterlife, which necessarily, by definition, makes Freemasonry an idealist and non-materialist thought system. Two, Freemasonry has a reverence for geometry. And a reverence for geometry is the reverence for the a priori truths of mathematics, which strongly imply that in addition to being idealist, as the first statement goes, it is also Pythagorean and rationalist. Geometry is true because it is true. And 3, this is profound because esoteric Masonry is both a haven against mainstream scientific materialist meta-paradigms and for religiosity, which is beyond mere faith. It's a higher synthesis of reason and intuition. And hence, Freemasonry implies a rational, intuitive view of the soul and of existence itself. Thank you. So we happy to take any questions? The fellow Greek philosopher.
Yeah, Brother Theodore, I'm extremely impressed. That was very esoterical and very scientific at the same time. And I, being a Greek and from a fellow Greek like you, as the colonel says in Casablanca, I expected no less. Again, extremely impressive. I wanted to add a piece of information. I have heard people who say that the geocentric system was also the egocentric. Why should the sun be the center and not the earth? We live the earth, therefore we had to be the center of the universe. Even Ptolemy said that. And Ptolemy is the one who placed the planets, as later astronomers said, in such a way as if he had been there at the time of creation. However, he was wrong about the geocentric idea. The one who was right about the geocentric idea and whose statue is at the Griffith Observatory just up the hill is who? No, a Greek astronomer of the ancient times. Is Hipparchus. You do not see the statue of Ptolemy up at the Griffith Observatory. You see the statue of Hipparchus. And he's the one who said that the earth was round and it was moving around the sun. And if somebody was to circumnavigate the earth, then they would lose 1 day's worth of time. Who was the first explorer to prove that? The astronomers of Magellan, because they are the ones who, for the first time in 1522, circumnavigated the world, and that was just about 15, 16 centuries after Hipparchus had made that calculation. Thank you very much, extremely impressed. I think this is one of the best, and I want to thank Brother Michael for recording and producing this. This is certainly going to be a Masonic philosophical treasure.
I actually like to add to the whole egocentric aspect. To this day, science is very much an egocentric exercise, and I'll explain exactly why. To a scientist, or a rising scientist, a budding scientist, that might have their heart and soul in a particular theory. Keep in mind, right, when we talk about theories, we use the scientist's name. There's Planck's constant, right? There's all these things, all these scientific elements that we are name after scientists. So there's a big part of ego involved. And so if a scientist, which is submitting peer-reviewed papers, has their heart and soul to prove this theory, they're not acting from a completely objective standpoint. Deep down, they want to be right because their name will be on it. And it does not to say that there isn't some value in the peer review process and all that, but we have to be skeptical to not be too dogmatic about the infallibility of the scientific method. No questions? Well, that good. Thank you very much for having me. It was a pleasure.